Hello and welcome to C++ Weekly. I am your host, Jason Turner. I'm available for code reviews and on-site training. In this episode, I'm going to touch on Bloaty McBloatface from Google. And you know the deal, make sure you check out the video description for t-shirts, upcoming workshops, swag, Patreon, all the things. Now, this one has been on my radar for quite a while to talk about. I don't even recall how long ago I put this on my list of potential episodes. The last official release was in 2020, but you can see that it is still being updated from time to time today. Now, the idea is that this is a binary size profiler. You can give it a binary and ask it for some stats about your binary, and it can tell you things. Like it can tell you which portions of your binary contribute the most to the size of your build. And this can be very interesting for those of us who are interested in knowing why the heck did our binary bloat from one release to another. And you can even do things like diffs between them. And I'm really not going to get deeply into this. I'm just going to show a couple of quick examples. Now, this is a project that I have been somewhat involved in for a while here called Energy Plus. I am not actively doing work on it, but it is an open source product. And this is a LTO build using the mold linker because, well, I have plans to do an episode about mold, but I haven't gotten there yet either. And you can see that 57.7% of the file size is in the text section. Well, that's just functions being executed. And then you've got your string tables and your read-only data. And it would probably be interesting to note that 10% of the size of this build is actually read-only data. That's kind of a lot. And there's a reason for that. It is because there is some data tables that are baked into this particular product. I can run the same thing against a build of ChyScript and actually see that string table and dynamic strings and such are actually more of the binary size than the actual executable text code. And I have virtually no read-only data, relatively speaking, 187 kilobytes, 1.3% of this particular build. And if it was a debug build, it would tell you what percentage of this was debug. Now, again, this has a million options, but I just did a full symbols dump, and it's telling me where my largest functions are. So the ChyScript bootstrap function is the largest function. It is currently taking up the most amount of space in the text section. And it was not able to demangle all of the symbols for some reason, but the prelude takes up a fair bit of size as well, and that's not surprising because that's a bunch of ChyScript script that runs whenever the scripting engine starts. And going back to the Energy Plus example, by running full symbols here, I can actually see that a fair bit of virtual memory size is spent in the fluid properties cached TSH. That would be interesting to look into. And not surprisingly, this embedded schema is where a fair bit of size is spent as well. And that's that read-only data section that we were looking at before. So there you go. This is Bloaty. It has just far more options than we can get into in this episode of C++ Weekly, but be aware that it does things like allowing you to set output formats that can be parsed later with other tools. You can specify whether or not you want it to disassemble functions. If you have got debug symbols in here, then you can get even more output from the thing. And it tells you when you look at the help, which things require debug info. It's all very interesting, and if you're concerned about tracking the binary size or wondering where binary size is going in your executable, you need to check out Bloaty McBloatface.